Gonna really try to not freak you out with this one. When we last left Owl, we had learned that the Olympics had came in here and backhanded us pretty well. Paired with forces that are happening down in Southwest America, the Pacific Plate is being pushed northwards into western Washington in what can only be described as a 50-million-year-old car crash. Do recall that these faults up here in the northwest part of Owl are exclusively strike slip faults. That is not what is happening in our next location. Owl in the red line takes a sharp right turn around Port Angeles and enters the Puget Sound Basin. Today's story takes place from Port Angeles, across the Kitsap Peninsula, through Seattle, and out to North Bend. And the story of the faults changes drastically because we get different kinds. In the western Washington area, there are several different surface faults, called surface faults because they're near the surface. Some of the more prevalent ones from north to south are the Darrington Devil's Mountain Fault, which is an oblique fault that runs from the San Juans through Mount Vernon and out to Darrington. Whidbey Island Fault, which is a oblique fault that starts near the San Juans, crosses the island through Mukilteo, and connects down with the Rattlesnake Mountain Fault, which is a thrust fault that goes from Duval to roughly Tiger Mountain. Seattle Fault, which goes from Hood Canal across the Kitsap Peninsula, right through downtown Seattle, out to Falls City. Tacoma Fault, which is another thrust fault that goes from Hood Canal, across the Kitsap Peninsula, across Commencement Bay, and stops in Auburn. And the White River Fault, which is a strike slip fault that extends from Enumclaw, across the Cascades, all the way over to Natchez. And the real humdinger with all this, all of these faults are capable of producing a roughly 7.0 magnitude quake. Insert meme of the dude with the big head saying that we're so effed. But I introduced to you there a new term that you likely haven't heard before, an oblique fault. Oblique faults combine the best of both worlds between a thrust fault in our area and strike slip faults. You can imagine when we have competing directions of Earth moving, a lot of damage can occur. Take our friend in the Seattle Fault, for example. 1100 years ago, a magnitude 7 struck along the entire length, with enough force to uplift marine layers almost 26 feet. If you've ever enjoyed a walk, a ride, a drive on Alki Way, you are on top of these marine layers lifted up. In a similar situation, you have oblique faults like the South Whidbey Island Fault, which has been dubbed by the USGS to be most likely to have the largest one in the area. Not a great award. All in all, though, the impact of Silencia, or the crescent basalt, into the coast of Washington, and then that clockwise rotation, is generally what's causing these faults. And they all track in line with Owl. One more curious thing. We touched on it in my video about glaciers in the city of Tacoma a few weeks ago, but this area was ran over by a lot of ice and a lot of material was left behind. All of that glacial material, as well as all the change that has happened here, makes it very difficult to find some of these faults, given the fact that they have roots almost 50 million years ago. And what this means is that we don't necessarily know the true extent of some of these. Take the Tacoma and the White River Fault, for example. These have been mapped by themselves, but notice that the Tacoma Fault points pretty much right at the White River Fault. And remember, in that glacial video, there are spots in this area that have almost 700 to 800 feet of total glacial material, which makes peering down there very difficult. A little suspicious, though, that they point the same direction. Furthermore, look at how some of the faults on the west side line up with the Palm Springs of Washington's fold thrust belt. I ain't letting that one go, Yakima. But the part of this story that makes everything complicated is the Cascade Range. Our next video, which includes everybody's favorite geologic topic, volcanoes.